Hey, Jarrett.
Hello.
How are you doing?
I'm good.
It's been a while. Things must have been going okay in math.
Yeah.
So, what's going on now? What would you like to do for the next 30 minutes?
I didn't do too good on the last test, so
Okay.
we just
Do you have the results back? Can we go over the problems that you missed?
I don't have the test with me now.
Okay. What do you have that we can work on?
I don't really have it. I could get worksheets out of my backpack, I guess.
Well, I don't have a clue as to what you've been going over, so I can't really bring the problems to the table. You need to.
Okay. Here, 1 second.
All right.
My dad says that we sent you an email with the chapter 1 and 2 tests on it.
Did you send it to David Cowan or David Cowan 1949? I didn't get any emails to my main email address. I do have, oh, hold on. No? Let's see. Here's your appointment. It was booked on October 16th. And I don't have any emails since then. I do have another email address. Let me check it real quick. Don't see anything in here either. Yeah, no, not recently. I don't know when he sent them.
We sent it from the email that's on your website, I think.
Well, I have two websites. The main one I use locally is Algebra to Calculus Tutor.
Yeah.
Well, I didn't get it. Tutoring for no, that's a new student that just contacted me. That's not you. I did not get it. Is there any way he can resend it, or you can resend it, or is it stuff that you can verbalize? Do you have it in front of you?
1 second.
Okay. do that. Whatever it is that's giving you difficulty, that's what we need to go over. And that's what I don't know. So.
Like finding the measures of angles without using, like, you know, they just give you one angle and then you have to find all the other angles. I had some trouble with that.
Okay. We're talking triangles here?
Yeah.
Okay. Well, these are a little tough to verbalize because they usually depend on some sort of a triangle. What are they giving you? What are they giving you and what are they asking for?
Well, they give you one angle, like f equals 63 or something, and then they ask you to find the other angles. Or
okay, is this a right triangle? Because the sum of the angles of a triangle equal 180 degrees. So if that one is 63 and that's all I know, I can't figure out the other two. But if we're talking a right triangle, then I also know that's 90, which makes that 37. In other words, in a right triangle, the two acute angles always total 90. But if I did not know that that was 90, I could not answer the question.
yeah. Systems of equations. I did pretty good on that, though.
Okay. Do you have a cell phone with a camera on it?
Yeah.
Yeah, you could take a picture of that material right now and send it to me if you want. Any of the graphical problems that are difficult to verbalize, if you can find problems that you can verbalize easily, then that's just as good a way to do it.
There's word problems.
Okay. Go ahead and read it.
A boat departs Port Isabel, Texas, traveling to an oil rig. Oil rig is located 9 miles east and 12 miles north of the boat's departure point. About how many miles is the oil rig from the departure point?
Okay, here's the departure point, right? Said it traveled 9 miles east, that's to the right, and 12 miles north. And they want to know this distance right here. Well, east and north are perpendicular to one another, so that's a right triangle. So we need to figure out this hypotenuse. How do we do that?
Pythagorean Theorem.
Yeah, that always works. So I can say that x equals what?
12 squared plus 9 squared.
Yeah, whenever you're solving a right triangle, always remember that the answer always begins with the square root of.
Oh, yeah.
So x is the square root of 9 squared plus 12 squared. And that's equal to 15. Now, how did I know that? Because that is a 3, 4, 5 triangle. In other words, the one triangle that you don't have to use the Pythagorean theorem to solve is if you have 3 and 4 on the sides. That's a 3, 4, 5. This is just a multiple of a 3, 4, 5. In other words, I recognize that that was 3 times 3. That was 4 times 3. Therefore, that's got to be 5 times 3. But, like I said, the Pythagorean theorem will always give you the answer. But it's good to recognize that triangle. You're going to get lots of problems over the next few years that it's going to be extremely beneficial for you to see a 3, 4, 5 triangle or multiple thereof. What else you got?
There's a similar problem. It's when Toby installed his own 30-foot flagpole, he added a wire with one end attached to the top of the pole and the other end attached to the ground 10 feet from the base of the pole to help keep the pole stable. How long was this wire show you work?
Okay, there's the picture. Here's the flagpole. Here's the wire. And he said the wire was 10 foot from the base of the flagpole. That makes this 10. So now what is x again?
The square root of 30 squared and 10 squared.
Good. Which is the square root of 900 plus 100, which is 1,000. Whatever the square root of 1,000 is. It looks like it would be 10 root 10. That number right there. And it's easy to make this mistake, either 10 or 100. In other words, it seems like the square root of 1,000 should be a nice round whole number, but it's not. In other words, 10 squared is equal to 100, and 100 squared is equal to 1 with 4 zeros, 10,000.
There's a question that asks how to prove if a line is perpendicular to. Wouldn't it just be the slope is the reciprocal of the other slope?
Yeah, in other words, if I have a line that has a slope of 3, if I want to prove that that line is perpendicular to the first line, then I have to show that its slope is the negative reciprocal negative 1/3. That's by definition, that if two lines are perpendicular to one another, I saw it put another way the other day, and that is that their slopes multiply to -1. Which is the same thing as saying the negative reciprocal.
There's a bunch of graphing stuff, but I don't really think I could.
Well, unless if they ask you to graph, we can do that. If they ask you to interpret a graph, that could be tough to do online. But if they just give you an equation and say graph it, let's do that. We can do that.
It's reflecting and rotation like symmetry and stuff.
Okay.
Reflection symmetry I get pretty well Rotation.
Let's do some rotation ones. Usually
Plot the point.
Go ahead.
Plot the points -7, 2, -2, 3, and -2, 7. And that forms a triangle. So then it says rotate ABC 90 degrees clockwise about the origin.
Okay, let me graph them, and then we'll talk about how to manipulate them. Okay, so there's our triangle. Okay, now what is it they want to do?
Rotate it 90 degrees about the origin.
Okay, clockwise or counterclockwise?
Clockwise.
Okay, so what we do is we draw a line to the origin from the closest vertex, and we rotate that 90 degrees so that that's a right angle. And now everything has to be put about that point there. Well, what happens to this point right there? What does it become?
2, 3.
Well, let's try that. Well, and now this point here, which got rotated by 90 degrees, is going to look something. In other words, this line here is now that line there. And what would this point here be? Which is the equivalent. Let's label these A, B, C. And this would be C prime. I don't think that's right, though. I don't think 2, 3 is right. Hold on. I don't want to give you wrong information. Let's see. Rotations. So when you rotate 90 degrees, let's see, here we go. So 4, 1 becomes -1, 4. So -2, 3 becomes 3, 2. This one right here. In other words, you switch the numbers and you put the proper sign. We can see they're both positive. Okay, so that's C prime, that point there. What is A prime?
2, 7.
Yeah, 2, 7. In other words, we switch the numbers and we switch the sign on the 7 because clearly that's now positive. And then, let's see, B ends up being over here. So B prime would be what?
7, 2.
Yeah. Interesting, they use the same numbers, but yeah. So that's how you do it. That's with a 90-degree rotation. If you're doing other kinds of rotations, like 180 degrees or 270 or something like that, then it's different. But 90 is that. What else you got?
Zoom factor.
Okay. Elaborate.
So it gives you a shape, and then you have to zoom by a factor of what it gives you, like 2 or 3,
Okay.
1.5.
So we're talking something like this.
Yeah.
And if you zoom that by a factor of 2, then you make all of the distances from the origin twice as far. In other words, this line here would extend, I believe this is the way it's done. Let's again label this A, B, C, D. This would be the new A prime. B, I would connect the line to the origin and extend it by a factor of 2. There's B prime. Same thing with C and D. So C prime is up there. D prime is way out there. Now connect the new points, and you get the factor that has been zoomed by a factor of 2. In other words, this is dilation and expansion, whatever you call it when you zoom out. I guess zoomed.
So 3, 3 becomes 6, 6.
Let me see if they have anything in my book. Are you in geometry?
Yeah.
Okay, I was thinking you were in algebra. Oh, that's right. It was algebra in the summer you were reviewing for geometry. Yeah. Okay. Let's see. I'm on the chapter of rotation and reflections in my geometry book. Who's the author of your geometry? Is it Larson, Boswell, Stiff?
We don't get a geometry book. We do all of our stuff online.
Oh, okay. Trying to remember where in this chapter the zoom is. The chapter I'm looking at has all about transformations, reflections, rotations, translations, glide reflections, and freeze patterns. Now, I know there is a place in here for zooming, because I looked at it once. I don't get very many students that have to do that. What school do you go to, Jared?
Thunder Ridge High School.
Okay. not sure my book covers that. It covers the rotations and glide reflections and stuff like that. But zoom factors, hold on now, I don't think it does. I'm looking at one now that appears to. It's a picture of a football that's been blown up. But I can't find anywhere in my book that talks about it. So, let's see, the next chapter in geometry is similarity, and that's kind of what you're talking about. In other words, the figure that I created on my page here is similar to the first one. It's just twice the size.
Yeah.
Now, you said, does this point 3, 3 become 6, 6? And I think the answer is no. Just notice what would happen if we had drawn that point right there. In other words, if this was point A, well, if I extend it, that point looks to be maybe 3, 1. If I extend it twice as far, does it become 6, 2? Actually, maybe it does. Looks like it might. Sure, it would have to, because the slope doesn't change. Yeah, no, you're right. It does. Whatever the coordinates are, they double. Yeah, in other words, the slope from here to here is over 3 up 1, so it's the same slope. Since the theory was to extend it by a factor of 2, you just continue the straight line and you do get 6, 2. So that's one way to do it. And if you do it by half, then just multiply the coordinates by half.
Okay.
Yeah, no, that would work. That would work even if one of them was negative. In other words, if we had our figure like this, in other words, by the way I said to do the zoom, this point, if we had A, B, C, D, well, the point that's tough would be D, but it stays negative if we just go out twice as far. Everything's twice there. In other words, that's 2x, 2y, if this was x, y. All right.
Okay.
Well, I hope we made a little progress today in helping you understand it. I will let you go and talk to you next time.
Okay, thank you.
All right, Jarrett. Bye-bye.